Okay, so in theory, you have done 6 questions in a worksheet on proportional reasoning. I am hopeful that you have actually done those questions. They are screenshotted from actual New York State exams. These are questions that that you can expect your students to have to know how to do. So if you can expect a 10-year-old to know how to do it, you should know how to do it. So I will work through my solutions and we will handle this together. A basketball player attempts 15 baskets. He makes 9 of the attempted baskets. Which ratio describes the number of baskets the player made to the number of baskets the player attempted? Made to attempted, we know that the player made 9 baskets. The player attempted 15 baskets. So can we reduce this fraction? Sure we can. Both of these have a factor of 3. 9 divided by 3, 15 divided by 3. And so that's the ratio. Sometimes it is written in this form, but that is the ratio you're looking for. We expect small children to know how to do this. A grocery store sells a bag of lemons at 5 lemons for $2. What is the unit cost of each lemon? The unit cost. So there are 2 ways that people do this. One is right and one is wrong. Sometimes people say, oh, look, 5 divided by 2, that's 2.5. And sometimes people say 2 divided by 5, that's 0.4. Well, what is it? A unit cost is a cost per item. If it's a cost per item, then the per tells us who's in the denominator. So the number of items has to be in the denominator. This has cost in the denominator. So it's $2 for 5 lemons. That's 0.4 per lemon. What's 0.4? 0.4 is 40 cents per lemon. And that's the unit cost. So unit cost is a cost per item. The per tells us what's in the denominator. Okay. There are 230 calories in 4 ounces of a type of ice cream. How many calories are there in 6 ounces of that ice cream? Let's think proportionally. When we think proportionally, we assume that every ounce of ice cream has the same number of calories in it. We know that this is roughly true. It's not completely true because there are more chunks of this in some ounces than in other ounces. I get that, but we assume for argument's sake that every ounce has the same number of calories. What is that number of calories? Well, there are 230 calories in 4 ounces, and that turns out to be, your calculator tells you 57 and a half calories per ounce. So if there are 57 and a half calories per ounce and 6 ounces, well, I know how this goes, and my calculator tells me that that's 345 calories. So this is proportional thinking. In proportional thinking, we assume that every ounce is the same, and we play off of that idea to use, so we basically scale down and then scale up. That's our plan. We scale down and then scale up. So we figure out how many calories there are in 1 ounce and then use that to figure out how many there are in 6. Some of you are familiar with a proportion, which is a big part of proportional thinking. There are 230 calories in 4 ounces. How many calories are there in 6 ounces? This is the exact same way to do this. You would have learned when you were young that we cross multiply, and so you would have figured out that 4 times the number of calories is 230 times 6, whatever that is, and then you would have divided. So let's just follow that through. What is C? C is 230 times 6 divided by 4. Well, how did we get that? We took 230 divided by 4 and multiplied by 6. And that's what happened up here in blue. So whether you solve a proportion or you figure out the number of calories per ounce and then scale up, you are fine. I will demonstrate that down here also. So Pat bounces a basketball 25 times in 30 seconds. How many times can Pat bounce the ball in 150 seconds? Well, if Pat bounces the ball 25 times in 30 seconds, well, 25 times divided by 30 seconds is 0.83 repeating times per second, right? It's the number of bounces per second. So then you have 150 seconds. Well, 150 times 0.83 repeating, and your calculator is going to be good with this, 125 bounces. So some of you are going to say 25 bounces in 30 seconds, number of bounces in 150 seconds. And you're going to solve a proportion by cross multiplying, and that's fine. I would even encourage you to say, if we scale up here by a factor of 5, we have to scale up here by a factor of 5. And sure enough, that's it. So no matter how you skin the proverbial cat, you've got to end up with 125 bounces. So the green method is a scale up, scale down thing. The red method is a proportion. Machine fills boxes at a constant rate. At the end of 35 minutes, it has filled 5 boxes. At the end of 35 minutes, it has filled 5 boxes. Which table represents the relationship? So we have to know that after 35 minutes, it's filled 5 boxes. 5, 10, 15, 20. Next up would be 25. 1, 2, 3, 4. Next up would be 5. That's not it. 35 minutes. 35 minutes. This is going to get really, really big, really, really slowly. 5 boxes. We've already passed that. That's not it. 35 minutes. 5. That's not it. So is it this? Probably. Count by 7s. Count by 1s. Yeah, at the end of 35 minutes, it's filled 5 boxes. So this is a unit rate of 7 minutes per box. And that refers to the slope of a line. If you were to plot all those points on a grid, their slope would either be 7, depending on where you put your minutes in your boxes, or 1/7, depending on where you put your minutes and your boxes. Last question from the front side of the sheet. Darnell's car used 8 gallons of gasoline to travel 340 miles. After a mechanic worked on the car, it used 7 gallons of gas to travel 350 miles. The price of gasoline was $4 a gallon. How much less did it cost the car to run? So before, at $4 a gallon, Darnell paid $32 to drive 340 miles, and your calculator will tell you that that's about 9 cents per mile. After the mechanic worked on the car, again at $4 a gallon, Darnell paid $28 to drive 350 miles, and your calculator will tell you that that's about 8 cents per mile. Well, how much less? 0.01, 1 cent less per mile. That's how much less it cost per mile to run the car after the mechanic worked on it. That's a pretty good margin there. I'd pay the repair if it made my car do that. So there are some other questions for us to consider. They are in another video. They are not on a worksheet. So you've got to take notes on that. I will see you there.